Pomodoro Joe for Monday, January 16th, 2023. Today we're looking at LeetCode problem 57, insert interval. This is a medium problem. And the problem statement says, you were given an array of non-overlapping intervals, called intervals, where intervals at index I is equal to a start and end. It represents the start and end of the ith interval, and intervals is sorted in ascending order by start. You are also given an interval, new intervals, with a start and an end, that represents the start and end of another interval. Insert new interval into intervals such that intervals is still sorted in ascending order by start, and intervals still does not have any overlapping intervals. So you need to merge the overlapping intervals if necessary. Then you return intervals after the insertion. They have an example, a couple examples, they have some constraints. One thing they don't say is whether or not this has to be done in place. The wording sort of implies that it does, saying return intervals after the insertion, but it doesn't specifically say you need to do this in place. So given that, let's go ahead and do this not in place first. It'll be a lot easier. And then if there's time, we'll do an in place solution. All right, so we'll set 25 minutes on a Pomodoro and get started. There we go. All right, what's the first thing we'll do? Well, since we're not doing this in place for this first solution, we'll create a result that's an empty list, and we will return our result. Okay, so here are the basics. We'll find all the intervals that come before, then we'll find all the overlapping intervals, and then we'll find all of the intervals that come after. That's what it comes down to. It's pretty straightforward. So let's see. We could do this with multiple for loops, but I think what I'm going to do is have just one index out here. We'll start at index 0, and we'll just say, while our index is less than the length of our intervals. And so these are all the intervals that come before. So we'll look at intervals at our index. And we'll look at, so how do we know if it came before our new interval? Well, one thing we do is we can compare the end of the interval. So it's tempting to say, okay, well, if this one starts before our new interval, then it comes before the interval. But that doesn't necessarily ring true. If the interval starts before but lasts a really long time, it might end up overlapping our new interval. But we can check if this interval ends before our new interval starts, then there's no overlap. So we'll check the end of the current interval in our intervals list against the beginning. So if the new interval begins after our current interval we're looking at ends, there's no overlap. And if there's no overlap, then we can just add this interval to our results. So our result, we can just append this intervals index. And then of course, because this is a while loop, we'll need to manually increment our index. Okay. So that gets all the intervals that come before our new interval, and it puts them in our result. Now for overlapping intervals, so we'll still have this while index of less than the length of our intervals. And now this is where we're looking for overlap. So we've already checked all the ones that came ahead of this new interval. So the overlap happens if this interval at our index has a start that comes before our new interval ends. And in fact, we will want to check if it comes before or if this interval starts exactly as our new interval ends, then we can merge them. So, all right, so how do we merge intervals? Well, one thing we'll need to do is create one new interval out of these two intervals. So we will be just modifying the new interval. So our new interval start will now be whichever start came first. So the minimum of the interval at index start, or our current new interval start. Okay, and similarly the end, the new interval's end, will be whichever ends later, so the max of the interval at index end, or our new interval end. Okay, and of course we will need to manually increment our index because this is a while loop. So now that we've merged these two intervals together, we're not going to append that yet to our output array. It's only once we've reached the end of all our merged intervals. So once we've merged all of our intervals together, now we need to append it to our result. And then finally, in our after, let's say I misspelled result, right? So now we have any interval that comes after all our merged intervals. And at this point, we don't even need to do any checks because we've merged everything. So anything that's left in our array has to come after. So we just say, well, index is less than the length of our intervals. We can immediately just append the interval at that index. And again, we will still need to increment our index manually. And at the very end, we return our new result. Okay, so that's pretty much it. We create some new list. We go through and we append all the intervals that come before our new interval. Then we find all the intervals that overlap with our new interval, create one new interval out of those, and append it to our result. And finally, we will append all the remaining intervals to our result. Let's see if that works. Oh, I've got some typo. This is intervals. All right, let's see how many more typos I got. Okay, that passes. Let's see if we can pass all the tests. And that passes all the tests. So this is the not in place solution. It beats about 87% of the other solutions in terms of runtime, and it beats 91% in terms of memory. That is surprising. All right, hope you had fun. Hope you learned something. We still have time on the Pomodoro though, so if you want, I will go over an in-place solution. All right, so let's remove all of this and start over. So this will be our in-place solution. Okay, how are we going to do this? Well, with the in-place solution, I think what we'll want to do is we will find all the overlapping intervals. So let's do that first. Find overlapping intervals. So we'll just call this overlapping. And it'll be a list of intervals. All right, go for interval in intervals. So this is very similar to how we did this before. So if this interval ends before our new interval starts, then there's no overlap and we can continue. If this interval starts after our new interval ends, then we can actually just break because we're done in our loop. Otherwise, we have an overlap and we'll add this to our overlapping intervals. All right, so our overlapping intervals, we'll just append this interval. All right, so now that we have all our overlapping intervals, we'll want to remove these from our array. we'll also want to create a new merged interval. So for interval and overlapping intervals, very similar to how we did this before, we'll have this new interval. Start will be the minimum of the two. So the minimum of our interval, or our new interval start. And similar with the end, the new interval end will be the maximum. Let's see, I clearly have something wrong. All right. Will be the max of our interval end, or our new interval end. Okay. And then we'll also want to remove this interval because we're merging. We'll remove it from our result, which is intervals.remove that interval. Great. Now we need to find the insertion index. Where do we put this new merged interval? We could have done this as part of this process, but I think it's a little bit easier to explain if you break it into steps. So merge and remove. And now we find the insertion index. So our index will be equal to 0. And then for our interval, actually we'll want to have an index for index and interval and enumerate our intervals. Okay, if our interval here, its start is before our new interval start. Let's say new interval start. So if the current interval starts before our new interval, then we want to insert our new interval someplace in the future. So we'll just say it's going to be index is equal to, I have too many things called index, so we'll call this insertion index. So our insertion index will be equal to our index plus 1. And at some point, if it's not, and we'll just continue. We could just keep going, actually. Let's just keep going. Make it simple. So that'll find our insertion index. So then we'll actually need to insert this new interval into our intervals. So intervals.insert, and this we give the insertion index first. And we give our new interval. And that modifies this intervals in place. And then we do still need to return the intervals. All right, we are out of time, but let's see how many typos I have. Let's see if this works. All right, let's see. So many typos. And that works. Let's submit that and see if we do any better than our previous solution, which was not in place. Not really. So this in-place solution only beats 55% of other solutions, and it only beats 52% of other solutions in terms of memory. So our previous solution, which was not in place, does much better in both memory and runtime, which is surprising. I would think that the memory would be better on an in-place solution. All right, folks, hope you enjoyed that. Hope you learned something. I'm out of time. I'm Pomodoro Joe. Please check out my other videos for more LeetCode problems, and please write better code.